Welcome students to this new session on conjoint analysis. Last session we saw how to formulate a conjoint analysis problem as a linear optimization problem. In this session what we are going to do is we are actually numerically going to solve a problem. So just to recall, the final linear programming problem that we formulated was this, right? So this was the final linear programming formulation where we defined a, j, kp as a parameter which is based on ykp and jkp, which are the attribute values. Similarly, we defined another parameter called bjkp, which is ykp and jkp again, dependent on the attribute values. We defined v as our new decision variable. We did some algebra, added up all the a values, added up all the b values, and then formulated the problem like this, where z was a almost a dummy variable. We defined that as a dummy variable, and then the first constraint was wp into ajkp plus vp into bjkp jkp plus zjk greater than or equal to 0. This is for all ordered pairs, which means that you will have one such constraint for each of the pairs. And we saw that the number of pairs will be n into n minus 1 divided by 2. The last constraint was almost like a normalization constraint, where it is wp into ap plus vp into dp is equal to 1. Right? Now notice, pay attention to the signs. We want weights to be greater than or equal to 0. Weights it doesn't make sense to have weights less than 0. So we want the weights to be greater than or equal to 0. We want the z variable to be greater than or equal to 0. However, we can leave the v variable, which is newly defined variable, unrestricted. Okay, so that was the formulation. This formulation, if you recall, came from the classic article written in 1973. The article itself is now popularly called the LINMAP article, LINMAP, right? And we saw the basic concept behind that. Since the formulation itself came from that article, I thought the numerical example also can be close to that article. I definitely didn't want to copy the exact example in that article. So the article, you will realize that also has a two attribute, so two attribute data and 5 product variants. Obviously, the numbers are mine. These numbers are mine. So this is the data available to us on the 5 product variants. Product variant 1 scores a 1.5 on attribute 1, a 12 on attribute 2. Product variant 3 scores a 2.3 on attribute 1 and 4 on attribute 2. Similarly, product variant 5 scores a 9 on attribute 1 and 1 on attribute 2. So this is the product attribute data. What else do we need to solve the linear programming problem? Of course, we need the pairwise choices. So choice data. So this is the choice data. So when we ask the consumer what does she prefer, this is what the consumer told us. Consumer told us between the pair 1 2. So this is for the pair 1 2. This is for the pair 1 2. She prefers 1 over 2. For the pair 1 3, right? This is not ordered, right? This is not ordered. However, this is ordered. So this is ordered pair. Between the choices 1 and 3, she prefers 3 over 1. Between the pair 1 and 4, she prefers 4 over 1. Between 5 and 1, she prefers 5 over 1. Between 2 and 3, she prefers 2. Between 2 and 4, she prefers 2, and so on. Right? Notice that since we have 5 product variants, right? N into n minus 1, n is 5, right? Here n is 5, n into n minus 1 divided by 4. So 5 into 4 divided by 2 will be 10, and we will have 10 pairwise choice data, right? 10. Count that these are 10. So 1, 2, 3, 4, 5, 6. Just to make sure that we have not missed out any pairwise combination, right? So all the 10 combinations are available. We have choice data for all the 10 pairs from this particular consumer. So this is our choice data. This is our choice data. This is the attribute data. This is the choice data. Now let us formulate and solve the optimization problem. Now let me take you back to the slide. This is the problem that we wish to formulate. This is the problem that we wish to formulate. Let us go to Excel. This is my optimization problem formulation. I have already kind of formulated the problem for you. So I'm just going to show you the cells and the formulae that I have entered. So this is the attribute data for five product variants, right? Same data. Notice that I have not changed the data. This is the same data, right? Now we need the A and B variables. We need the A and B, not variables, A and B parameters, A, J, K, P parameter and B, J, K, P parameter, right? So for the ordered pair JK, A, J, K, P is essentially thus the attribute data for the kth variant and then the attribute data for the jth variant, right? So when we say A121, right, ordered pair, I have already put an order here, JK, AJK1, right? So this is your AJK1. J is 1 here, K is 2 here, right? So this means what is this? This means J is 1 here, K is 1, K is 2 here, P is 1 here, right? So AJKP, right? AJKP. P is the first attribute. P is the attribute and P is equal to 1 means first attribute. So then we take the attribute for the kth variant first, square it, and then subtract it from the squared value of the jth variants attribute. So then it will be y21 squared, right? Y21 because this here it is here here we mean this is YKP, right? This is YKP because K is 2. K is 2. So this is YKP and this is YJP. YJP. Right, and obviously P is 1, right? P is 1. Why do I say that? Let us go here. Let us go to the definition. Right. So first we want the kth variant and then we want the jth variant. So hopefully we have done this right. So this is your kth variant and then your jth variant. Now what is y21? Y21 is 10, which is this 10 here. What is y11? Y11 is 1.5, which is here. Right. Remember this entire thing is to demonstrate the values for the first attribute. Similar exercise will have to be done for the second attribute, right? Where P is actually equal to 2. Here everywhere we have assumed that P is 1, right? P is 1 everywhere. All these illustrative numbers essentially come from P is equal to 1, which means the first attribute. Now I'll show you that we have done the same thing for attribute number 2 also. So what is AJK1? AJK1, how will you write AJK1? AJK1 will be this 10 squared minus 1.5 squared, right? So essentially I wanted to automate this whole numerical data pulling. So I have used the VLOOKUP function, right? Anyway, the Excel sheet is going to be made available to you. So you can actually make sure that I have used the VLOOKUP function in Excel correctly. Hopefully I have, right? Hopefully I have used it. So it is essentially what is this cell doing? This cell is calculating 10 squared minus 1.5 squared, right? You can verify this. That this is 10 squared minus 1.5 squared. Oops. No, this is not 10. I want this guy. Okay, so 97.75 is the correct value that we have calculated. Now, why is this negative 3.01? 1.5 squared minus 2.3 squared should give us negative 3.04. Just verify. Let us verify. Let us do that for one more time and then we know that we have done it right. So 1.5 squared minus 2.3 squared. and that should give us negative 3.04. So that is also correctly calculated. So these are all AJK1 values which are essentially calculated because I already had these values readily available. Even though I did not use them, I made the equation more generic because I'm directly pulling, I'm not pulling values from this 10 here, I'm pulling directly values from the table. In fact, I have to look up, right? If you notice, I'm looking up in A2C2, right? A2C2 of pairwise choices. A2C2 of pairwise choices. So A2C2 of pairwise choices is this, right? This I'm looking up here, right? If you noticed, I have to go to pairwise choices, and then the column, then the cell D2 from there, and I look up that D2 in this column A of this cell, right? So you know how to use VLOOKUP function. I have done the same thing for AJK2, where P is actually equal to 2. All these calculations are essentially for P equal to 1. All these calculations are for P equal to 1. Hopefully I have done this right. And why do I know that? Because in the VLOOKUP equation, I am referring to column index 3. Column index 3 is this column index C, right? C essentially is for attribute 2, right? This is the column index C, right? This is the column index 3, third column. Third column is the C column. C column is for attribute 2. Similarly, I am using 3 here, this 3 here. This 3 here indicates the column index 3. Column index 3 is clearly for column C, and which is for attribute 2. So I'm using, hopefully I'm using the correct equation when I calculate the values, AJK values for attribute 2. So this is AJK2. Now what was our B equation? B was simply negative 2 into, right? Negative 2 BJKP was negative 2 into the Y attribute values for the kth variable, the kth variant and the jth variant, right? So hopefully, how is this 10 calculated? This 10 is calculated as negative 2 into this minus this. Hopefully that turns out to be negative 17, right? This negative 17. Once again, this is for 1, so this is for attribute 1. So all these values are for attribute 1. You should be able to readily verify them. Because they are right here. They are right here. Values for attribute 2 are not readily available to you. You will have to pull them using VLOOKUP function, even though I have pulled even these using VLOOKUP function. How do I know that this is for attribute 1? I know that this is for V attribute 1 because I have used column index 2. Right, this is the column index 2. Column index 2 is column B. Column B is for attribute 1. So all these values are hopefully for attribute 1. Similarly, I have calculated, even though this should be small b, right? This should be for attribute 2, the B parameter. Right? So B parameter is defined. Right? B parameter is defined. Okay, so AJK1, AJK2, BJK1, BJK2 all calculated. Now what else do we need to calculate? Summation values. The summation of all the AJK values and summation of all the BJK values for that particular attribute. That is simple summation sign. I have calculated this as summation of all the AJK values for attribute 1. 64 to be the summation of all the AJK values for attribute 2. This 2 represents the summation of all the BJK values for attribute 1. This represents summation of all the BJK values for attribute 2. So these are your AP, and these two are the APs and these two are the DPs, right? DPs. APs and BPs also, DPs also calculated. Now let us define that decision variables. Where are our decision variables? Decision variables are the W's and V's. Where are my decision variables? Decision variables are right up here, right? W variables and V variables. Okay. Let me show you the calculations. So let me show you that this is what we get. So let me erase all this. First of all, let me show you all the values. So here I want Excel to print the value for W1. Here I want Excel to print the value for W2. Let me show you all this. Doesn't matter. I can okay. Right. Here I want Excel to print the values of V1. Here I want Excel to print the value of V2. Now these are all the Z variables. Now where are these Z variables? Look at the formulation. Right. So for the first constraint, which is an equality, I want to use the dummy variable ZJK. Right. ZJK for each pair. So for pair 1, 2, only Z1, 2 should come here, not any other Z variable. When I'm considering pair 1, 3, only Z1, 3 should come in the constraint. When I'm looking at a pair 4, 5, only Z4, 5 should come in the constraint and none of the any other Z variables, right? So these are my pairs 1, 2, 3, 1, 4, 1. Why is it not 1, 3? Why is it not 1, 3? Why is this 1, 2 and 3, 1? Because look at the pairwise data. It is 1, 2 because it is ordered pair 1, 2, but it is 3, 1 because it is ordered this way. Even though the pair is 1, 3, the ordered pair is 3, 1. Therefore, we have written this as 3, 1. We have written this as 4, 1. Why 4, 1? Because the customer prefers 4 over 1. So we want to correctly order it and only define that variable. So there we have not defined Z14. Z14 is not defined because look at the formulation. It is for the ordered pair JK. For the ordered pair JK, we have a variable ZJK. Since there is no ordered pair KJ, right? We will not have a Z variable KJ. There is the ordered pair is only 4, 1. So I will only have Z4, 1. I will not have Z14 in my formulation because look at this. Consumer prefers variant 4 over variant 1. Therefore, I will not have Z14. I will only have Z41. Similarly, I have Z51, Z23, Z24, Z25, Z43 corresponding to all the ordered pairs. 3, 5, 4, 5, right? 3, 5, 4, 5. These are all the ordered pairs and therefore I have those corresponding Z variables, right? I have learned to say this as Z variable. Some of us said this as call this as Z variable. Doesn't matter. We are referring to the same variable. So these are your Z variables. So this is what I have told Excel to print the Z values here. Now, how do I write the constraints? Let me write the constraints with numerical values in them. Then we will delete the numerical values. Where is my formulation? This is my formulation. So what is the formulation? For any ordered pair, anyway we are in the ordered pair, right? This is the ordered pair 1, 2, right? This is the ordered pair 1, 2. So this entire row corresponds to 1, 2. This entire row corresponds to 1, 2, right? Okay, so what is the constraint? For every ordered pair JK, AJKP into WP plus BJKP into VP. So where is my AJKP? These are my AJKP. Where is my W? My W. Where is BJKP? My BJKP. Where is my V? These are my V. Right? Plus the lone Z variable. The lone Z variable for that particular ordered pair. The lone Z variable for that ordered pair. So we have put a 1 here. There is no other Z. So we have made it 0, 0, 0. There should not be any other Z variable in this constraint. So we have made this as 1. All the other Z's are 0. How do I write this constraint then? I will write the constraint value which is WP into A variable plus V into B variable plus the lone Z variable. So I will simply write this as sum product function of this row, of this entire row where my data is, and this row where I have asked Excel to print the values of my variables. V is my decision variable, W is my decision variable, and Z is also my decision variable. Okay, so this is how I have defined the left hand side of the constraint, right? And this has to be for each ordered pair. So for pair 1, 2, this is the constraint, right? This entire thing, right, multiplied by this entire thing. If you understand the concept now, for the second ordered pair, it will simply be sum product this row from this row, right? For the third ordered pair, it will be some product of this row into the row where the values of the variables are. Similarly, for the next ordered pair and 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 the next ordered pair, all in all, there will be 10 such constraints, each corresponding to each of the ordered pairs. Now, what is the constraint? Constraint left hand side we have calculated as a sum product function. The right hand sides are all zeros, and the constraint is an inequality where the left hand side has to be greater than or equal to the right hand side. So these are all the n into n minus 1 divided by 2. So 10 constraints of this type. Right, 10 constraints of this type. Let us make sure that we have not missed out. 3, 4, 5, 6, 7, 8, 9, 10 constraints. All these 10 constraints. So hopefully we have not missed out on any ordered pair. That chance was minimum because we had anyway defined our a variables at least for the first attribute here. So we made sure that we have not missed out on any pair. Therefore, hopefully here we have not missed out on any pair. And anyway, the ajk and the bjk values have been calculated using VLOOKUP function. So once C6 is once this pairwise, right? This pairwise is right. So this is D2, right? This will be D4, right? And the last will be D11. D11. So look at this. D11 is really the D11 and the B11 are really the last entries. After that, the VLOOKUP function will not find any entries and therefore will not be able to calculate the AJ values and the BJK values and so on. Right. So once it hits D11 and B11, that's it. You can't calculate anything further. The VLOOKUP function will not return a sensible value. And that is another way of ensuring that we have accounted for all the ordered pairs. So all the 10 ordered pairs have been accounted for. Let me delete that out to avoid confusion. Otherwise, we don't want any confusion here. But remember that what constraint is this? What constraints? These are what constraints? These are 10 constraints which correspond to this first constraint here. This is for each ordered pair, so I have 10 such. Now the last constraint is a single constraint. This is not for every ordered pair. It simply says summation of WP into AP plus VP into DP. So where is that? Where is my AP? AP summation of all the AJK variables. So this is my AP. So this is my A1. This is my A2. This is my D1. And this is my D2. Right? So as the formulation says, AP, which means that for every P there should be a capital A value. So A1 and A2. For every P there should be a capital D value. So D1 and D2. So I have all the 4 values that are calculated here. And what should it get multiplied with? So the formulation says W1 into A1 plus W2 into A2, V1 into D1 plus V2 into D2. I can simply do that I can do that very, very manually by saying A1 into W1 plus A2 into W2 plus D1 into V1 plus D2 into V2. I can do that, right? I can do that. But why do that? I can simply use sum product function just the way I have been using, right? Sum product function, and that once remember that this sum product function does not include the Z. So I have only taken the A1, A2, D1, D2 values and corresponding W1, W2, V1, V2 values. Notice that in the last constraint there is no Z variable, there is no Z variable, and the sign is an equality and the right hand side has to be equal to 1. Right hand side has to be equal to 1. So this is the left hand side, this is the right hand side. You will get a left hand side equal to 1 right now because the problem is already solved. Right. So okay, what is the objective function? Where is my objective function? My objective function is summation of Z values. For each ordered pair JK, I will add up the corresponding Z values. So for each ordered pair JK, I will simply add up the z variables. Where is my value? Where are the values of my z? These are the values of my z. So my objective function is simply summation of all these values. Summation of all these values. Right. So that is my objective function. It's a minimization object. It's a minimization object.